Good afternoon, alien enthusiasts, and welcome to another special bulletin from Space Nest. I honestly wasn't planning to dive back into the saga of 3I Atlas so soon, as my schedule was packed with other pressing astronomical matters. There were several other topics I intended to cover, including deep dives into the propulsion systems of future probes. One of those topics involves a recent launch from the Indian Space Agency, which has achieved some truly remarkable milestones in cost-effective engineering. Some things associated with that launch are very interesting, and my previous videos covering Indian spaceflight have proven quite successful. I have picked up a massive number of viewers from India over the years, and I truly appreciate your support and technical insights. If you have any interest in that kind of topic, make sure to tune in because I'm going to be releasing a dedicated video on that very soon. All that having been said, however, 3I Atlas has jammed its way back into the headlines, demanding our immediate and undivided attention. It has returned not because the mainstream media wants it to, but because it refuses to behave. As far as most of the mainstream scientific and space-related periodicals are concerned, 3I Atlas has made its close approach and is effectively old news. They tell us it is heading out of the solar system, fading into the dark void of interstellar space. As far as anybody in the establishment is concerned, it's already gone, and we should just close the book. They insist that we don't need to pay any more attention to it, urging us to focus on more conventional targets, like asteroids or standard comets. This is exactly, I think, what these people would like to have happen, as it saves them from having to rewrite their textbooks. They would love to have all of the drama associated with this strange object vanish into the ether. They would like to stop saying that it is a natural comet and stop arguing with people like us over the data points that don't fit. They want to sit back on their laurels, content in the knowledge that they were right all along. They want to believe these alien enthusiasts were just out of their heads from the beginning, chasing phantoms in the dark. But the facts, the hard data, and the new developments with 3I Atlas seem to be very inconvenient to that whole school of thought at the moment. The reality of the situation is refusing to align with the comfortable narrative of a dirty snowball. Because 3I Atlas, after its close approach with Earth and after reaching perihelion, is doing something impossible. After getting to a point where a comet should be calming down because it's getting further and further away from the sun, it is waking up. Therefore, logically, it should become less bright as the solar energy stimulating it fades away. Its tail should be less obvious, shrinking as the sublimation of gases ceases. That sort of thing is Astronomy 101, the basic behavior of every comet we have ever catalogued. Instead, things are happening with this object that are becoming more dramatic, more intense, and more bizarre, the more we look at it. Good afternoon, once again, and welcome to the skeptical side of the cosmos here at Space Nest. So, I have really, as most of you probably know, enjoyed talking about 3I Atlas for the last several months. It has been a fantastic experience sharing all of these new developments with you and watching the mystery unfold in real time. And really, despite what the naysayers claim, there is still a lot of road ahead of us. 3I Atlas is not going to reach the Hill radius, its closest approach with Jupiter, until sometime in March. That means we have months of gravitational interactions to observe and analyze. It is going to be well within the confines of the solar system throughout 2026, giving us a front row seat to this interstellar ballet. We're not exactly sure how long it's going to be visible to our instruments, as its behavior is erratic. It will probably be visible to our best telescopes, like the JWST and ground-based observatories, until sometime in the summer. This depends, of course, on how bright 3I Atlas remains and if it decides to vent more material. But as of right now, as of this point where it's still nowhere near Jupiter, the show is far from over. It still has many millions of kilometers to go before it reaches that close approach with the gas giant, but still far beyond its point of perihelion with the sun, far beyond its point of perigee with the Earth. 3I Atlas is continuing to throw us curveballs. It is continuing to behave in a way that no comet has ever behaved before in the history of recorded astronomy. And as usual, the most significant and amazing development with this object is in regards to its anti-tail. The anti-tail has always been a very prominent feature of 3I Atlas, confusing observers from the very first images. Usually, a comet's main tail, the dust tail and the ion tail, are the stars of the show. Actually, most comets have two conventional tails that trail behind them, pushed by the solar wind. These have always been more prominent, more obvious to the naked eye, or more obvious to our telescopic observations in standard cases. The anti-tail, although very considerable in some rare historical comets, is always maybe half or a third the size of the main tail. It is certainly a lot smaller than the regular tail because of the physics involved. It should be smaller because an anti-tail is effectively fighting against the solar wind, whereas a conventional tail is traveling with it. Anything in nature should generally go with the flow, following the path of least resistance. But that's not what's happening anymore with this intruder. The new anti-tail that we are seeing from this object is the most spectacular anti-tail we've seen thus far, eclipsing the main tail in significance. The more we look at it, the less natural it seems to be, and the more it looks like a driven exhaust plume. Now, the first new image that the Hubble delivered to us is less than impressive to the untrained eye. It looks like a smudge, like so many other raw images that we've seen from Hubble before processing. But hang in there, because the data hidden in those pixels tells a frighteningly complex story. There's a lot more impressive stuff to come once we peel back the layers of noise. This is the raw image of 3I Atlas, captured on December 27th, just 2 days ago. It was taken with a 1 in 72 second exposure by the WFC3 UVIS instrument of the Hubble Space Telescope. It was captured at a central wavelength of 0.5851 microns, putting it squarely in the visible light spectrum. So, just looking at the raw image, there is nothing particularly exciting to report. But here is where things get a lot more interesting for those willing to do the math. This is also a 172 second exposure from the same instrument on the Hubble Space Telescope. However, it is processed through what's called a Larsen-Cecchinina rotation gradient filter, which enhances contrast and structure. This processing reveals a stunning double-jet structure that was invisible in the raw data. The left panel displays the data on December 12, 2025, and the right panel on December 27, 2025. The relative brightness of the two jets changes drastically between these dates, implying a dynamic shift in the object's orientation or output. This change is either due to jet rotational wobble or significant source variability. And as you can see, the brightness is dominated by the anti-tail jet directed at the Sun towards the lower left side. Again, this has never happened with any natural comet in history to this degree of intensity. This is an unbelievable anti-tail, not created by an optical illusion of perspective. It is created by some kind of legitimate phenomena that is actively defying the solar wind. Now, a sunward jet, which is 10 times longer than it was wide, was already captured by the Hubble on July 21, 2025. And its 7-degree wobble is a crucial piece of the puzzle. Now we know that's how much it is wobbling around the rotational axis of 3I Atlas. This means that the source of the jet must be within 7 degrees of the pole of 3I Atlas, the rotational pole. So this implies that it originated near the sun-facing pole long before perihelion. Now, after 3I Atlas encountered the Sun, it should have experienced a gravitational deflection of about 16 degrees. If the rotational axis did not change between July and December, the original sun-facing pole is now on the night side of 3I Atlas. It is now opposite to the direction of the Sun, meaning that this prominent anti-tail shouldn't exist anymore because the source is pointing the wrong way. At this point, the original anti-tail is now pointing in the same direction as the weaker jet in the new Hubble images from December 12th through the 27th. It is accompanied by a stronger sunward jet from the opposite side of 3I Atlas on its way out of the solar system. Once again, this absolutely shouldn't be happening if this is a passive rock. You shouldn't get a duplication of the same kind of jet if different sides of the object are facing the Sun. This is especially true after the perihelion close approach, which alters the thermal dynamics of the surface. But that's exactly what is happening before our very eyes. We're getting essentially a mirror image of what 3i Atlas looked like in July compared to what it looks like now. At least with the anti-tail being more prominent, just as it was in July, the symmetry is suspicious. Now, one possibility is that the two jets are launched from opposite sides of the nucleus. This would make the post-perihelion activity of 3i Atlas different than it was before perihelion. For a natural comet, heat conduction could theoretically transport the excess solar energy near perihelion from the day side to the night side. This could activate a weak jet on the night side, in addition to a stronger jet on the day side. But for a technological object, the explanation gets a lot easier and requires fewer thermal gymnastics. The sunward jet might be utilized for protection against the solar wind and radiation. It could be shielding the craft from coronal mass ejections, which had been really common during this period of high solar activity. And also, we need to keep in mind that the anti-tail is marginally opaque. It is a lot more difficult to see through than the so-called regular tail, acting almost like a smokescreen. In addition, the secondary jet could mitigate risk from obstacles lying along its path. Now, the second interpretation is that both jets originate from the sun-facing side, but they have a different composition. In other words, you have large particles that are being ejected from the same point, and smaller particles as well. The smaller particles are being blown away from the sun by the solar wind, behaving as expected. However, the large particles are somehow forming this massive anti-tail, driving into the wind. The anti-tail jet at this point can now extend up to several 100 million kilometers for dust particles with a radius on an order of 10 microns. However, the sunward outflow would extend only to a few million kilometers in the sunward direction for submicron particles. On these smaller particles, the solar radiative deceleration is 10 to 100 times stronger. A quick turnaround would also apply to gas particles, which are swept away by the solar wind instantly. Or it would apply to dust particles with a slow initial speed that cannot fight the radiation pressure. All of these particles could therefore turn around quickly and constitute a second jet heading away from the sun. All of this makes sense if we had seen anything like this before in our records. But we just haven't. And that is the crux of the issue. The true origin of the jets can be inferred from measurements of the velocity profile of the two jets. This will be based on future spectroscopic data from large telescopes like the Keck Observatory in Hawaii, or perhaps from the Very Large Telescope in Chile, which has the resolution we need. In the second interpretation, the weaker jet would also show a launch base on the sun-facing side of the nucleus. It would accelerate to an increasing recession speed with distance in the direction away from the sun. In a technological context, however, both jets are expected to show a high speed exceeding 1 kilometer per second. This high velocity would occur at their launch points near the nucleus, indicating a propulsive force. So, we need a spectrographic analysis of both of these tails immediately. And we really need to try to figure out just how fast all of the particles in these tails are traveling relative to the main body. If it's exceeding 1 kilometer per second, it's very unlikely that this is being caused by any sort of natural warming from the sun. Any natural warming should only drive particles out from the nucleus at a speed of about 500 meters per second at most, and the only way that they're going to be able to defy the solar wind is if these particles are much larger than the types of particles we see in other cometary tails. So why do the jets look so different on December 12th and the 27th, by the way? Well, remarkably, the relative brightness and projected shape of the two jets did change significantly between December 12th and 27th. That is a mere 15 days for a massive change in the brightness and shape of these jets to occur. This could be a signature of rotational wobble if the two jets are misaligned with the rotational axis. If they are misaligned with the rotational axis of 3i Atlas, the perspective shifts rapidly. But the difference could also indicate large variability of the jet sources themselves. A simple way to identify the cause is to compare snapshots taken at different times over the 30-minute observing windows on both dates. We can then identify systematic changes in them to see if the wobble matches the rotation. Now, The two Hubble images on December 12th and 27th seem to favor the rotational wobble interpretation. The anti-tail jet brightens when the opposite jet weakens, as expected from the wobble of a double jet structure around the rotational axis. Now, A.V. Loeb has argued that the wobble or variability of the jets may explain a heartbeat change. This change was observed with a period of 16 hours in the brightness of 3I Atlas in July of 2025. Yeah, that's right, this object had a pulse. 3I Atlas became brighter and more dim every time it rotated every 16 hours. As a result of mass loss, the rotational period of 3I Atlas may have changed by now due to conservation of angular momentum. It may have dropped down to around 15.5 hours or so, or perhaps it is even less than that, if the mass loss was catastrophic. Avi's team is going to attempt to measure this possible evolution as they analyze this latest Hubble data on 3I Atlas. So there's still a lot of unexplained and uninvestigated information about 3I Atlas that has yet to be looked into. But once again, let's look at the dust and the strange size of these particles. Because once again, that sort of perhaps explains how the anti-tail can exist in such a hostile environment. How big are these particles going to be to survive this journey? Well, the characteristic radius of these dust particles is on the order of about 10 microns. This is much, much bigger than any particles that you would usually find in a cometary tail. And this conclusion is based on not only the fact that particles this big would defy the solar wind, they also cannot be too big, or the physics falls apart in the other direction. If they were too big, they would keep on going in defiance of the solar wind for millions of kilometers. They would not stop at just 1,000,000 kilometers, which is what we are observing. That being the case, then you can calculate how big these particles can be based on the amount of time they survive. We look at how long they last before the solar wind finally obliterates them or pushes them back. Let us assume that a significant fraction of the total mass loss of the perihelion is carried by these 10-micron dust particles. The mass of each of these dust particles is roughly 10 to the 8 power grams. This is very lightweight in human terms, but massive for cosmic dust. But you have to consider how many of them there are as well to create this level of brightness. Based on how much particles of this size would tend to reflect sunlight, you can actually come up with the surface area. We can calculate how much light is left over, and therefore how big the nucleus of 3I Atlas might be. And Avi Loeb has calculated a minimum nucleus diameter of 2 kilometers right now. This calculation is based on the amount of light that particles of this size would reflect, combined with the amount of light left over. Therefore, the amount of light being reflected by the nucleus is the key variable. Assuming we're only talking about reflected light here and not from any sort of light being generated by the nucleus itself. If this was a technological object that is generating its own light, then this dust might actually be more of a protective blanket. It could be shielding the craft rather than just being the source of reflected light. In which case, 3I Atlas might have a radius of around 700 meters or so. That would give it a total diameter of about 1.4 kilometers. Once again, this is the minimum size, 2 kilometers, if we assume natural reflection. It might be substantially bigger than that if the albedo is lower than we think. But this is minimum size based on the particles that are reflecting the light. It takes into account the size of the anti-tail, the nature of the coma, and that sort of thing. And by the way, I can't begin to explain all of the calculations that go into how AB figures all of this stuff out. Suffice it to say that he knows a lot more about the stuff than I do, and his math checks out. But in summary, this blanket of dust that seems to be surrounding 3I Atlas is highly suspicious. These much bigger particles that reflect a lot more light are on the borderline of being opaque and transparent to sunlight. This means that imaging by an external camera with a sub-kilometer spatial resolution would have failed to resolve the surface. It would have shown a fuzzy cloud of dust rather than a nucleus with a sharp boundary. 3I Atlas is making it very, very difficult indeed for us to see what is actually at the center of this mysterious coma. If these are much larger particles of dust, or whatever they are effectively a cloak. In my opinion, they could also be nanomachines of some kind swarming the main vessel. The amount of reflected light that they are creating is hiding the true nature of the nucleus almost completely from our view. So, what do these new Hubble images tell us about the future of this encounter? Well, they tell us that this object is not going away anytime soon. Even as it starts to exit our solar system, its behavior continues to change and evolve. This double jet structure, with the anti-tail being far more pronounced, is the smoking gun. The so-called regular tail should be a lot more pronounced simply because of the enormous power of the solar wind. That's not happening, and physics demands an explanation for why. And not only is it not happening, what is happening seems to change every few days. The anti-tail changes, the primary tail changes, and the brightness fluctuates wildly. Even the color of this object is changing as it moves through the vacuum, and we need to keep watching it all the way out of the solar system. We must observe it until we simply can't see it anymore to try to ascertain more about its true nature. One thing we can say for certain is that the standard model is broken here. This is nothing like a conventional solar system comet, and we need to stop pretending that it is. So once again, is 3I Atlas a natural object? Well, maybe, if you stretch the definition of natural to its breaking point. I'm not going to go so far as to what A.B. Loeb says and say that it's probably a natural object. He cites its strange trajectory and how useful that trajectory would be to an object exploring our solar system. Or perhaps an object that's trying to seed the moons and planets of our solar system with life. He talks about moons and planets that would be receptive to this type of seeding. Seeding these things with organic compounds and such, perhaps to encourage the development of life on these moons and planets. This trajectory would be so incredibly useful to any sort of probe. It would be perfect for any sort of object that wanted to achieve these kinds of goals. So, it's very difficult for me to say that it's probably a natural object, when a natural object would not naturally have a trajectory like this. Sure, it might have happened at random, as anything is statistically possible. But the odds of this happening purely by chance are millions to one. You have to combine the astonishing characteristics of the trajectory with all the other weirdness that we've seen from it. But still, I continue to believe that it could theoretically be a natural object. All of these things could be a coincidence, a perfect storm of anomalies. Everything else that we are seeing could just be bizarre and unique characteristics of interstellar objects. Perhaps we have never observed this before, simply because they didn't originate here. But still, the natural processes that are necessary to make some of these things happen are extreme, especially the anti-tail, the tightly formed collimated jets going for such an enormous distance. 1,000,000 kilometers straight into the teeth of the solar wind is a feat of engineering, not geology. And being sustained that way for such a long period of time requires a consistent energy source. That just doesn't seem very natural to me either, no matter how you spin the data. And it really disappoints me that almost nobody in the field of astronomy is willing to stick their neck out. No scientist, no scientific journalists, very few people aside from A.B. Loeb and a few other firebrands in the field are speaking up. Very few are willing to say that it might be the product of an extraterrestrial civilization. It is so disappointing that we continue to have such a narrow view of the things that we observe in the universe. And when we continue to talk about Enrico Fermi and his famous paradox, we miss the point. Where is everybody? He asked. In my opinion, Fermi's paradox doesn't exist. It is a failure of observation. We see signs of extraterrestrial civilizations in the universe around us all the time. We just refuse to acknowledge their existence, or refuse to acknowledge that they might be the products of extraterrestrial civilizations. We have conditioned ourselves to reject the obvious if it feels too sci-fi. We continue to look for any natural explanation, regardless of how unlikely it is. We twist logic into knots for the phenomena that we see in the universe, rather than consider the alternative. We refuse to consider that they might be the products of extraterrestrial civilizations. And if even 1% of the unexplained phenomena that we see in the universe are the products of a civilization other than our own, then everything changes. That means the Fermi paradox never existed to begin with. They are here, and they have been for a long time. They are all around us, watching and waiting. And perhaps they haven't reached out to us because we're just not important enough to them. Or perhaps they've reached out to us in ways that we can't understand because our technology is too primitive. Or perhaps they haven't reached out to us because it's a bad idea to do these sorts of things. In the dark forest hypothesis, silence is survival. It could be that very powerful and advanced technical civilizations have a tendency to crush any other civilization that could theoretically present a threat in the future. And if that is indeed the case, well, we've been broadcasting our location for well over a century now. We have been shouting into the void, inviting anyone who can hear us to come visit. Eventually, one of these dangerous civilizations is going to detect us. And eventually, they're going to come for us. Not to shake hands, but to sanitize the threat. Now, all I can say is I hope that the dark forest hypothesis is not a correct one. Because if it is, we've already blown it, and Tri Atlas might be the scout. Thank you very much for watching another Space Nest Bulletin. Please don't forget to like and subscribe to help us beat the algorithm, and also, please consider supporting this channel on Patreon so we can keep asking the hard questions. Also, the 3i Atlas merchandise is making a comeback by popular demand. We're going to go ahead and re-release that line of shirts and mugs. We're going to open up the store again, hopefully before New Year's Eve or immediately afterwards. It may already be open by the time you see this video. I don't control that side of the business, actually, Sunline does. But nevertheless, we're going to have some of that stuff available for you again, at least for a limited time. So, keep your eyes open and grab a piece of history while you can. Thanks again for watching and for keeping an open mind, and until next time, Space Nest is signing off. Keep watching the skies.